Hello everybody, today we're going to be talking about how forensic scientists use DNA to convict criminals. I hope you enjoy. Last time we learned about what forensic scientists are, how they help people and help solve crimes, how they use evidence, and how they isolate DNA. But now we're going to be learning about a new method called gel electrophoresis, which forensic scientists use to study murder scenes or other crimes. What is gel electrophoresis? Gel electrophoresis is used to sort DNA strands by length that are separated by restriction enzymes. This is incredibly useful for comparing samples of DNA. Gel electrophoresis works when you put your DNA in the wells of an agarose gel, a gel that looks a lot like jello, but we do not eat it. After that, we run an electric current throughout the entire gel. Why is that? Well, that's because that DNA can actually go through the gel. Since the DNA is negatively charged, it moves to the positive section. And so, the reason why it goes to the positive section is because, as we all know, opposite charges attract, whereas like charges repel. You'll see that the larger strands of DNA don't move as quickly or as much as the smaller strands. So, why is that? Because they have more mass, and because of that, they can't move as quickly. It's a lot like saying an elephant can't move as quickly as a cheetah, because the cheetah is much smaller than an elephant. So, here we can see that this whole pattern, as we can call it, is called a DNA fingerprint. And everyone has their own type of DNA fingerprint. So that's a DNA fingerprint. It's all of those strands combined. So, how do we use these to solve crimes? Well, that is very easy. Let's look at this. This is the DNA fingerprint of some blood that was spilled at a crime scene. This is the DNA fingerprint of suspect 1, suspect 2, and suspect 3. So how do we know which one is the actual killer? Well, that's very easy to figure out. All we can do is try and match up the DNA fingerprint with the suspect. So, over here we have the crime scene. So, does suspect 1 have a line over here? Nope. So that means suspect 1 cannot be the killer. Can we check suspect 3? Suspect 3 doesn't have a line over here either, but it does one have over here. But you can see that they don't actually match. So we can also rule out suspect 3 too. And finally, we can check out suspect 3. Suspect 2 has this in check, and it also has this in common. As well as this, we can also go down and we can see that they too have this one in common, this one in common, and this one in common as well. And since they have all of them in common, that means we can say that the DNA fingerprint from crime scene is actually from suspect 2. So we can say that suspect 2 was the killer, or the stealer, or whatever crime he did. Goodbye, and I hope you liked this video.